In this example, we're going to pull together all of our learning from this unit to analyze a function from a calculus perspective. So the first function here is a rational function, 3x squared over x squared minus 1. And one of the things I always do is, before I even graph it, I see if I can factor either the top or the bottom of my function. And the bottom factors into x plus 1 times x minus 1. And those are the values that will break my domain. So this helps me determine any asymptotes or vertical asymptotes and will help me with my sketch. So at 1 and negative 1, I know that I'm going to have a vertical asymptote since those factors don't cancel out. I also consider whether or not I'm going to have any horizontal asymptotes. And I think that I will, because if I generalize here, this function is going to become 3x squared over just x squared. That minus 1 as it gets bigger and bigger is not really going to mean anything, and the x squareds would cancel, and I'm going to have a horizontal asymptote at y equals 3. So on my sketch, I'm going to put in a dotted line at y equals 3, and that will help me make my sketch. Now, since I'm kind of going out of order here, which is fine, I'm going to go over to my vertical asymptotes before I even toss this in my graphing calculator, and I've already said I know I have one at x equals 1 and x equals negative 1, and I have a horizontal asymptote at y equals 3. Now, I would encourage you to graph this on your graphing calculator, and when you do, you're going to get this very interesting graph that looks like this. And there's like a parabola here in the center part between my asymptotes. Okay, so now let's go into some of our different parts here. We're going to go to our domain, and I've already established that I factored the denominator, so I know that both factors in the denominator would cannot equal 0 or it breaks my domain. So x minus 1 can't be 0 and x plus 1 can't be 0, so I know that both negative 1 and positive 1 will break my domain. So I'm going to say that it goes from negative infinity to negative 1, union, negative 1 to 1, union, 1 to infinity. And there's my domain. To get the range, I'm going to look at my graph a little bit here that I looked at the graphing calculator and used my knowledge to get parts in here. So it's going from negative infinity up to this point right here. So what is that point? Well, where does it hit the x-axis or my x-intercept? That's going to come from setting y equal to 0. So I'm going to just zoom in here for you. And that's really going to come from just the numerator of the function, because you could almost think of this like a proportion. If you cross multiplied, you're going to get 3x squared equals 0. And if 3x squared equals 0, what does x equal? Well, it equals 0. So it's hitting the x-axis at 0. So here's my x-intercept. And now that's going to help me with my range. So let me zoom back out for you. All right, so my range is again going from negative infinity to 0, and 0 is included, union, and then I've got a horizontal asymptote that it approaches but would never ever touch, so 3 to infinity. Now let's talk symmetry. I'll zoom in to do that. But before I do, it definitely looks like I have even symmetry with symmetry about the y-axis, but I'm going to confirm that algebraically. To do it algebraically, I remember I substitute in negative x into my function. So everywhere there is an x, I replace it with negative x. I'm just going to rewrite it. And now I'm going to clean it up algebraically. And when I square negative x, that's going to produce positive x. Same on the bottom. So I get the exact same function that I started with. So f of negative x equaled f of x, my exact same function, therefore my function is even. All right, proven it algebraically, and I, of course, confirmed it graphically. So zooming back out, next we are going to talk about continuity. So because I have vertical asymptotes, I am going to say that there is infinite discontinuity at x equals positive and negative 1. Let's look at where this function is increasing. So from left to right, it's increasing negative infinity. 2, we've got this break at negative 1, and then it continues to increase until we hit 0, which is written as negative infinity to negative 1 union negative 1 to 0. Remember, it's neither increasing or decreasing at an individual point, so we always use parentheses. And then this function decreases from 0 to positive 1, and then 1 to positive infinity. Okay, so let's look at any extrema that we observe. So in this parabola right here, I have a max. It would not be an absolute max because your function goes infinitely higher. So the absolute max here would be 0. That's the y value, and it occurs at x equals 0. So you could say I wrote that as local max of y equals 0 at x equals 0. To find our y-intercept, we just plug 0 into the function, although I think you've already observed that it's crossing at the origin. But you would do f of 0, you just plug in, and that produces 0. Now let's talk the limits of the function. So out on the left, as x approaches negative infinity, what is the function approaching? It's approaching your horizontal asymptote of 3. And the same on the right. These are both approaching 3. I will just zoom in so you can see as a reminder how we write limits, and they're both approaching 3 on the left and the right. So this is pulling together all the important parts of this unit.